Hello and welcome to our STEAM project number 11, featuring the Raspberry Pi Pico and MicroPython. This level is part of our Sherpa level series, designed for the somewhat experienced STEAM teacher. Today, we'll create a virtual dice game that can be played by a single player. Your class is going to love it. My name is Peter, I am the founder of Educomondo and a certified STEM instructor and course developer. The goal of today is to develop a game where a player throws a virtual die. That die has 9 LEDs representing the pips. We will work with a random function to generate a secret integer between 1 and 6. We will also create an interaction between the computer and the player on screen and with LEDs. We will develop 2 programs with increased automation using lists, dictionaries and for loops. And, most importantly, make sure your class works as a team to find solutions, help each other and present their project in a clear way. This is what we will need for this project: the large breadboard with the Pico installed and the pinout reference card, nine red LEDs, nine resistors of either 150 ohm or 220 ohm, a whole bunch of short and long preformed wires, and I have also made a small cardboard die to organize the LEDs. This is how the project looks like when finished. It is not difficult, but because of the many LEDs, it is easy to make mistakes or to have the resistors touch each other. And this can cause a short and the project will not work perfectly. So your students will have to work very attentively. You can also show your students this fritzing drawing, so they will be able to construct the project in their own small team. And once they are finished, they can connect the Pico to the computer and open Thonny to create a new program. The next part of this video is a live recording of the programming, and hopefully also a good example how we can solve errors by checking the RPI messages. Well, welcome to our Thonny environment and this live recording. So we want to create a dice throwing game. And what do we need for that? Well, first of all, we will need from machine to import the pin. We will also need some delay, so from time we will import sleep, and from random we will import the random generator, so rand int. Because we are using 9 LEDs to create the dice, we will need to create them. So the first LED 1 is going to be the pin number 11 that we have used, and it's going to be a pin dot out. And I'm going to copy paste this one a couple of times because we will need to create it for 2, 3, 4, 5, 6, 7, 8, and 9. And so LED number 2 is going to be pin number 12. LED number 3 is going to be pin number 13. LED number 4 is going to be pin number 14. LED number 5 is going to be pin number 15. 6 is going to be 16. 7 is going to be 17. And 8 is going to be 18. And 9 is going to be 19. So those are the pins that we have used to connect the LEDs via the resistors. And the next step that we want to do is to create a function. And as we have seen, this is done by DEF. And we are going to, first of all, create a function that is going to put all the LEDs on off. So we are going to turn them off. And we will call this function let off, and we don't need any parameters or any other elements closed or next to that. So what do we do? LED 1 is going to be off. And once again, I'm going to copy paste the same for LED 2, 3, 4, 5, 6, 7, 8, and 9. So I'm just going to change quickly the LEDs here. 3, 4, 5, 6, 7, 8, and 9. Right, so that was already some quite tedious typing. Now the next function that we need is actually the rolling of the dice. So we are going to call this rolling, and again open and close the rounded brackets. And the first thing that we need to define is, of course, the random number, and we will call that roll. That variable, we will call it roll, and roll is equal to rand int, and this time it's going to be between 1 and 6. So this is actually telling the or the program is actually going to create a variable called roll, and that variable will be a randomly chosen number that goes between 1 and 6. Here we can print it in our RPL. We can print a nice motivational message, like for instance, let's roll the dice, and with a exclamation mark, because we really want to motivate the player. Now we're going to compare what the dice actually is, what the random number roll is, and if that number equals 1, we will have to print the number of pips, the dots on the dice, is going to be that number roll, and we will have to put on a certain LED. We have to switch on the LED, the corresponding LED. So if it's 1, we will have to put on LED number 5, because that's the middle LED. So let's give it a try. So roll, print, let's roll the dice, and the next step is if roll, and of course it's with a capital R, is equal to 1, what do we do? Well, first of all, we print number of pips, and that is the variable roll. Next is that we are going to put let 5 on. We're going to switch it on, and we will leave it on for a given period of time. So let's say we want to leave it on for 2 seconds. It will give us sufficient time to see also on the LEDs how many LEDs are actually being switched on. And don't forget that we need to call the function let off, and we simply do that by typing LED off, open and close the brackets. So that's the first one, and now we have to repeat that for all of the other ones. So if roll is equals to 2, so if that random number is 2, what do we have to do? Well, we have to print first again the same number of pips and the variable roll. And this time we will have to switch on LED 1 and 9 because those are the two outer LEDs that we want to show and that we want to switch on when the variable number, the random number, is 2. So it's going to be LED 1 is on and LED 9 is on. We will keep them on for 2 seconds, and then we will call the function again, the function that is switching off all of the LEDs, so that none of them will remain on when we throw another dice. And it continues. If roll is 3, then we have to print once again number of pips, the variable roll, and this time it's going to be LED 1, LED 5 and LED 9, so that it's a quite nice, that is showing 3 LEDs the way that it is also shown on a real dice. So LED 1 is on, LED 5 is on, and LED 9 is on. Okay, well, we are now halfway. If the roll is 4, what do we want to do? Well, we want to print. Well, maybe I can copy paste this one. At least that is going to be easier, and maybe I can also do this. Let's do some copy. So print number of pips remains the same, but number 4, and what we want to do is we want to have actually the 4 outer LEDs to turn on. So that's LED 1, the other one is LED 3, the other one is LED 7, it's that's 7, and then the other one is LED number 9 to switch on. And we will sleep for 2 seconds, and we call the function let off, and we go for the next one. And this time I'm going to copy paste I already notice a small error with the if. It's not capital I, but it's small caps. So when it's 5, we will print the number of pips, and we want to have all the outer ones, but we also want to have the middle one. So let 5 is also going to be switched on, and now we can use the same. And for the last one, if number 6, when we throw all the pips, we will have 1, let 2 is going to be on, 3, but also 1, 2, 3, or we can probably use the outer one, so it's going to be 1 and 3. It's probably going to look a little bit nicer, 1 and 3. Then it's going to be 4 and 6. let 6 on, and then it's going to be 7 and 9. Is that correct? So 1, 2, 3, then 1 and 3, 4, 5, 6, so 4 and 6, and then it's 7, 8, 9, so 7, 9. Yes, so that should be the ones that we want to show. And now we just have to run the program, and we want to use a while loop. Our while true, and when it's true, it's always true, so it's going to continue the game. And I just need to call the function that we have defined here, rolling. I just need to call that, and there is no certain parameter, so I just have to type the open and close the brackets. And if we want to play it again, so I'm going to create here, play again is the input from the user. Input, and first of all, we want to ask him throw again each time, and then this user has the opportunity or the choice to type in yes or no. So yes or no. And we are going to make sure that if the user is going to type something wrong, like for instance in small caps, that it is automatically switched to upper caps, so that the computer understands that it is either a yes or a no. And it's the same logic and the same code that we have used in our previous lesson. So if the play again is different from, so exclamation mark, from yes, what will happen? Well, then we have to thank the player. Thanks for playing. Oops, playing. Playing. See you soon again. And don't forget to close the brackets. And then we break the program. Good. So let us have a look whether it if it will work. Just going to run it, and it seems to be working. So I want to just make sure always that you put the cursor in the right field. Oops, this is crazy. Throw again, yes, but then it says, thank you, we don't want to play again. So what is going on? I already know what it is. We have to put this in between rounded brackets. So let's give it another try. Number of pips is 4. Do you want to play again? And I have to be in this field. So always be careful. Yes, now it works. 6, and it works. And if I just don't do anything, then it creates it as, yeah, this is different from yes, and it closes the game. So this part works. Let us now go to the next one and try to make this a little bit more complicated and a little bit smarter. Not complicated, but smarter. So we will go in our next live session. Okay, so here we are with a new Tony, and again a live recording, because this time we are going to see if we can make our previous code a little bit shorter by using the power of our computer and of the program and of the microcontroller, and that is to calculate repetitive tasks very quickly. Because, as you have noticed, we had to do quite a lot of manual typing in our previous program. So there must be an easier way to do it. So let's give it a try and make the previous code a bit more elegant. Now we start with, of course, our modules and classes. Those remain the same because from machine we will need to import pin. From time we will need to import sleep, and from random we will need to import rand-int. Our first block of code in our previous program was just assigning to the LEDs that they are the pin outs. And we had to repeat it for all of the 9 pins. So why not create a list that is actually going to do that work for us? And we create a list by square brackets, and for pin with the variable j will be pin out. So we will have one pin, and it has a certain number. It is a variable number j, and it's going to be a pin out. Now, for when do we do that? For j in range of, where are our pins? Our GPIOs were 11 till 20. So for those, and of course don't forget to close with the square brackets. So those pins actually, so by j, and it's going to run from 11 till 19, is going to give it a value, or it's going to tell that it's going to be pin out. Good, so that's the first one. So with one line of code, we have actually changed or replaced 9 lines of code from our previous program. The next thing is that we're going to define a function that is going to turn on the LEDs. So turn on LEDs, and we are going to give this an argument, and that argument is a variable pattern. For j in range, and this time the range is not 1120, but we have 9 LEDs, so it's going to be a range of 9. And what will happen when the j variable is actually going and running through that range from 0 to 9, or from 1 to 9, it's going to put the LED, so our list, the j, an element of j, and it's going to give the value of the pattern of j. This is going to turn on the LEDs based on a pattern. Now, of course, you may ask, but what is the pattern? We'll come to that at a later stage, because pattern will be a library. It will be we will create a library of a pattern of zeros and ones. And we will add a small sleep, a small delay, maybe of half a second. So you can adjust this to any desired sleep time that you want to create a certain effect. But let's start with half a second. The next function that we want to define is actually rolling the dice. Oops, the dice. And we don't need any other qualifiers next to that. And this is where we are going to, first of all, define our variable, and this time we call it roll. For instance, roll is a random number, a random integer from the range 6, between 1 and 6. And here we can already, just like in our previous one, print a little prompt for the user, and let's say, let's roll the dice. and we can end with an exclamation mark just to motivate the player. And this is a good place to actually define the pattern. So pattern, and we know it's a library, so we start with the curly brackets. And this is actually the only time where we have to do some typing and be very attentive, because we are going to create again lists within the dictionary. So the one, we know that one is from the 9 LEDs. It's actually the LED in the middle, which means that from the 9 LEDs, from LED 1, 2, 3, 4, 5, we only need number 5 to be switched on and all the others off. So it's just 0, 0, 0, a 1, 0, 0, 0, 0. Just type, see if you have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's our first pattern. The second pattern, and remember this is about having keys and values in our dictionary. This time we're going to have 1, because it's the two outer, the left and the right bottom one. So it's 0, 0, 0, 0, 0, 0, 0, and now we are at the outer one, so we are going to close the bracket again. The same for 3. 3 is 1, let 1, let 2 is off, so 0, 0, this one is on, 0, 0, 0, and 1 again. This is where you have to be careful not to make any mistakes, but even if you make a mistake here, you will very, very easily, first of all, see it on the LEDs, on the dice, and you will be able to then quickly correct it here in these patterns, in these lists. So 4 is 1, 0, 1, 0, not 2, 0, and then again 0, 1, 0, 1. Okay, so that's number 4. And then number 5 is going to be the following pattern. So it's 1, 0, 1, 0, 1, 1, 0, 1, and then again 0, 1, 0, 1, if I'm not mistaken. And then the last one, 6, is going to be the following pattern. It's 1, then it's 0, then it's the outer one, then it's again the next row, and then 0, again the next row, and then it's 0 again, 0, sorry, 1 again, and then 0, and then 1. Okay, so that's the way it should be, and I close with a closing curly bracket. Okay, so that was a bit of an attentive typing. What's next? Well, we want to call our function turn on LEDs, because that has to actually follow this pattern. So turn on LEDs. So calling the function is simply just typing it, but this time we have to add the patterns parameter, and the patterns are defined by the role variable. So what this line says, well, you have to turn on the LEDs, but you need to follow the pattern that is being defined by the variable, the random variable roll. So if the dice rolls 4, then the pattern has to comes from the dictionary 4, and it's going to be 1 0 1 0 0 0 1 0 1. So that's the logic. And what do we need to do? Well, we can have a print, and this print we can do it two different ways. We can use this F and open quotation marks, number of pips, and again in between curly brackets you put the variable roll and you close the bracket you close the curly brackets, and with a quotation mark and with a rounded bracket. But you could also use our print command by simply typing here the same, so number of pips and a comma with the variable roll. It will both give the same result. But because we only need one, I'm going to put this as a comment, so we will not need it. I think that's about it for all our functions. So let's put it now into a while loop. So while true. And what do we have to call? Well, we have to call the function roll the dice. Roll dice, open and close the brackets. And we can use actually our very same code that we did in our previous version. So play again. Play again is asking the input from the user, and the input is going to be, do you want to throw again? So throw again. Throw again. And the user has the choice between yes and a no. That's it. And as we have seen, upper, and don't forget to open and close the brackets again. Again, that upper is to make sure that when the user is typing a small caps Y, then it's going to be interpreted as a full or a capital letter Y. So play again, so that's the input. So if that play again input is different, so exclamation mark equal from the yes, so the capital yes, and it's turned capital through this upper suffix, then we print a nice thank you. So thanks for playing. See you next time. And we break the program. Now there is one thing, there is one thing that we still need to do, namely we have to turn off all the LEDs after exiting the loop. And for how we do that with a simple for loop, so for all the LEDs, the variable LEDs in our LEDs, in our list of LEDs, the LED.value is put to 0. So this is also a very nice and easy way to turn off all of the LEDs. I think this is it for the programming. Let's give it a try and run the program. And yes, we have an error in line 29 and in 24. So let us have a look what 29 and 24 is. So 24, turn on LEDs. I can already see it. So in the name error says patterns isn't defined. So I have to check why patterns is not defined. And it is because I defined it as pattern and not patterns. So let's give it another try. And yes, it is working this time. So I'm going to see whether it continues to work when I type yes, and I have 3, yes, 6, and so on. And just to show you that it is also working. So everything seems to be working. I hope it works for you and your classes also. If not, you remember, no panic. Let your classroom do some logical fault finding, and I'm pretty sure that they will be able to solve the error or the issue. If not, I know they can always call on you to give them a little bit of help. Okay, that was it for the live recording. Before we wrap up this lesson, here is a nice bonus in case you want to include a 3D printing project in your STEAM projects. Follow the Tinkercad link in the description to print an LED holder in the shape of a die. That's it for lesson number 11. I am quite confident that you and your class enjoyed it. Now that we've covered some more game development basics, let's make it even more interesting and program a game that contains multiple dice and multiple players. And we'll let them compete against each other. I look forward to seeing you then. Bye bye for now.